All right, everybody, we're going to continue our exploration of nomenclature. We have a new type of molecule here. You see there's multiple rings involved. We call that a bicyclo molecule. So we're going to do this one and this last one here, because look, clearly that's a bicyclo. And maybe we can learn from here how this is laid out, even though they're different molecules. Okay, when you're looking at a bicyclo, the important thing to do is to spot what's called the bridgehead carbon. They are the only two carbons in the molecule shared by every possible ring. So I'm going to put blue dots here and here. Those are special carbons. These bicyclo molecules have their own rules in addition to the rules we learned last week. One of the new rules is one of those blue dots must be carbon number 1. So there's two ways to number it. And you got this new rule. One of those blue dots must be number 1. So the red option will explore that one being number 1. And from the inside, we'll explore the option of this one being number 1. New rule number 2. It's a bicyclo compound. When you have multiple rings, it'll have this in its name. We're going to come up with this part of this name first. The bicyclo bridgehead carbon. So one of those will be carbon 1, I promise. We don't know if red or green is a better choice. Rule number 2. Carbon 2 has to be in the biggest ring. So I believe it's a bigger ring going to the right than the left. Let's verify, going from 1 to whatever. 1, staying on the outside, 2, 3, 4, 5, 6, 7, 8, 9. And then the new rule number 3. After you've got past the first two bridgeheads, where does carbon 10 go? In the next biggest ring. So don't go up. This is a very small ring in the middle. There's a bigger, much bigger, we call it a bridge, by the way. To get from bridgehead to bridgehead, there's 3 ways to use it with bridges, to do it, sorry, with bridges. And we did the way from 1 to 9. That was 7 extra steps. There's a clue. How many carbons between 1 and 9 without counting 1 and 9? 7. Here they are. 1, 2, 3, 4, 5, 6, 7. How many steps getting back from 9 to 1 going this way? 1, 2, 3, 4, 5, 6. Get you 10, 11, 12, 13, 14, 15. And then where's 16? Well, you can't count 1 again. So 16 is as close to 15 as possible without counting 1 again. So that's one method of numbering this thing. And you'll notice the first group is on carbon 13 going this way. Have you noticed that? The other way has the same rules, so you got to go to the biggest bridge first. And then the biggest ring here, and I see already the green is a superior numbering system. Why? Back to our original rules of nomenclature. The direction that gives the lowest possible number for the first group is the correct direction. And green puts the first group on 12. Red puts the first group on 13. Green wins. And I'll finish the green numbering. You don't have to put any numbering on your molecule, by the way. I only grade the final name. 16, 17. Okay, so what's the third number? Well, there's one way to get from bridgehead to bridgehead I didn't count, and that's this way with 2 carbons in the middle, 2 bridge carbons. Did you know these numbers can tell us how many carbons are in the ring system? Add up all the numbers and add the 2 dots. The dots are actually the bridgehead carbons. This dot is a carbon, and so is this. Remember, they only got counted once. They never got counted in any of the numbers. It's how many steps extra between the bridgeheads. That's these numbers. And the dots themselves are, you know, I'll even make them blue here to make it very clear. Bridgehead, bridgehead. So 7 plus 6 plus 2 is 15, plus the 2 dots is 17, and we already knew that. Heptadecane, because we numbered the molecule. But I didn't have to number the molecule. Just had to count steps. I didn't have to get to 17 to figure out it was 17. There you go. We got groups on carbon number 12 in green. Green wins. Green numbers were 12 for the first group and 12 for the second group. Red was 13 for the first group, 13 for the second group. Doesn't matter. The first one told us, whoops, don't cross off that. Cross this off. Green wins. So we have an ethyl on 13. 12, sorry. 12, ethyl. What's that other group on 12? Yes, somebody said propyl. Here it is. 1, 2, 3 carbon groups, propyl. And what should go right in front of the square bracket? The word bicyclo. There you go. I snuck it in there. That's all I would grade on the test. The final answer. There you go. And with that in mind, I'm going to start the last answer. I put 2 blue dots. This morning I did horizontal. I'll do vertical in the evening. It doesn't matter. The best way to do bicyclos when you're given the name is draw the 2 dots first. Then draw the number of steps in between. It doesn't matter. Left, right, middle, first, second, third. Doesn't matter. I'll go 6 extra carbons to the right, and it doesn't have to be pretty. 2, 3, 4, 5, 6. Just make sure you added 6 new carbons. 1, 2, 3, 4, 5, 6. And then 5, I'll go zigzags. 1, 2, 3, 4, 5. And then in the middle, 1. Didn't have to be in the middle, could have been the outside. I don't like my 1. Nice sharp edge there. Good. You decide carbon 1 this time. One of those blue dots, that's all. Top, why not? Where's number 2 if you do that? Which of those bridges? Right, left, or middle? Remember, biggest bridge first. To the right. Yeah. 2, 8, 9. I did that kind of fast, didn't I? Well, I know, hey, going from 1 to 8 without counting 1 and 8, there's your 6. Yeah? And then 9 is there, and I stopped because my name only has a group on 9. I don't care about numbers after that, do you? I don't either. How do you draw a pentyl group on 9? Talk to me. How many carbons in a pentyl group? 5. There's 1, 2, 3, 4, 5. Got a little curly Q in the end there. Done. Bicycles aren't that bad. You have a question?
Did you draw 5 carbons on the left side?
1, 2, 3, 4, 5. Maybe 6. I don't know. I'll try. 1, 2, 3, 4, 5. 5 instead of 4. Ah, you caught me. Good. I'm glad you caught me. Better now than after the video is made. Trust me. Quick fix. Cut that down to 5. 1, 2, 3, 4. 4. I need 4, not 5. And it's not clear that's a carbon. I mean, I know it's a dot. You're gonna start thinking it's those bridgeheads. No, you're not. I'm just trying to make it ultra clear. Those corners are dots. They're carbon. You can use dots instead. Well, every time carbons meet if you want. takes more time, but what's special about the blue dots? They're shared by all the rings, right? You can't say that about these two green dots. They're just normal carbons on the left side. Yeah, now it's 641. 1, 2, 3, 4, and 1. Okay. Now we'll do the other one. Got my picture in the way. 4, cyclobutyl. What the heck's cyclobutyl? That's a ring, right? But it's a group. It's a group. And 5 has fluoro and another fluoro, 2 fluoros. And 4, 8, and 8 have propyls each, and there's 3 of them. And undecane. That's not hard. We're going to start by drawing the end always. Small typo. There's 2 L's there by mistake. Too big. I'm gonna have to just get some white out going here. There you go. Now it looks like there's a space. Okay, tripropyl undecane. I'm drawing 11 carbons in a row. 2, 4, 6, 8, 10, 11. Verify. 1, 3, 5, 7, 9, 11. Good. Want to go right to left? Why not? On carbon 4, I got a cyclobutyl. 1, 2, 3, 4. How do you draw a cyclobutyl? There is a bond. And you got to make sure the corner of the cyclobutane is attached. Remember that. You watched this morning's video, and I have a side comment, and this actually meets the middle of the square, and you'll see the square became a pentagon. If you're attached here in the middle of a bond, that's a new carbon. Don't do that. Just make sure it's a corner. You're not sure what I just said? Watch the morning video. Okay? And what else we got? We got fluoros on 5, 5. That's 2 fluoros on 5. That's 5 over there. 4, 5, 6, 7, 8. Propyl, how many carbons in a propyl? Sorry, say it again. I think you're thinking pentyl. That's a very honest mistake with them both starting with the letter P. The one that does make sense, if you say it to yourself, is the pentyl, right? That actually has a hint in it. So always you start with that one, no matter whether you see propyl or pentyl. Say the pentyl to yourself, and you know that's the 5. The other P is the 3. Like that? You made that rhyme. So 3 on 8, and then another 3 on 8, and another 3 on 4. There you go. So I think I got it all, don't I? I got a cyclobutyl on 4. I got fluoros on 5 and 5, and I got 4, 8, 8 tripropyl. Yeah. Good stuff, huh? Next one ends with cyclopentane. How do you draw that? How do you draw cyclopentane? Anybody? A pentagon, exactly. You decide carbon 1, put a bromine there. Don't worry about wedges and dashes till you're done. And 3 has a butyl. How many carbons in a butyl? 4. So that's carbon 1, 2, 3. 1, 2, 3, 4. And what does trans mean? There's a couple ways to do this. No, I can't do it that way. One has to be a wedge, and if one's a wedge, what's the other one? A dash. So I can go wedge for the bromo and dash for the butyl. Once again, please watch that morning video. There's a picture where I stopped that dash halfway. And if I did that, then my butyl group's now a pentyl group because you added a new carbon. Not sure what I mean? Watch the morning video. Another way to do the same molecule and get full credit is to reverse what's the wedge and what's the dash. Oh, what are you doing to me, buddy? There we go. 1, 2, 3, 4. They both would get full credit. Please don't do both on the test, just one. And that brings to a conclusion our first nomenclature section for today. And there we go.